Welcome! This is the 17th in my series of climate mythbusters, and the myth I'm going to bust today is that there's only 0.04% carbon dioxide in the atmosphere, which is far too small an amount to be affecting global climate. Okay, let's start with the misconception here. The first statement they often make is carbon dioxide makes up only 0.04% of the Earth's atmosphere. And that one happens to be true. In fact, it's just set a new record high at 410 parts per million. The second statement is that is a far too small an amount to be having any significant impact on global climate. That, as I will show, is completely untrue. The third conclusion they draw is that therefore we don't need to stop emitting more carbon dioxide. But if that second statement is untrue, then that third statement is also untrue. I maintain that the percentage of carbon dioxide in the Earth's atmosphere is completely irrelevant, and I'm going to show you a little thought experiment that will demonstrate that. Let's take a cylinder that's got an area of 1 square centimeter and is 1 meter long. We're going to put some carbon dioxide in that cylinder, and just the right amount that if we should shine 100 IR photons in one end, that exactly half of them will be absorbed or scattered away. So only 50 IR photons will come out the other end. So that's 100% carbon dioxide atmosphere. Now we'll repeat this experiment with a slight difference. So here's our tube with our carbon dioxide in it, the same amount as we had before, but now we're going to add exactly the same amount of nitrogen to the cylinder. Now the thing about nitrogen is that it's completely transparent to IR photons. So when you put 100 IR photons in one end, the nitrogen presence will make no difference. We've got the same amount of carbon dioxide as we had before, so only 50 IR photons will come out the other end. But now we have a 50% carbon dioxide atmosphere and a 50% nitrogen atmosphere. So the change of percentage of carbon dioxide in the atmosphere is making no difference. We can take this even further. Now we've got the same cylinder, but now there's 3 times the amount of nitrogen in the atmosphere as there is carbon dioxide. But remember, it's still transparent, so when you put 100 IR photons in one end, you'll still get 50 IR photons in the other end. But now you've got a 25% carbon dioxide atmosphere. Now you keep on adding other gases until you end up with the mixture that the Earth currently has, which is 0.04% carbon dioxide, 78% nitrogen and 21% oxygen. Oxygen and nitrogen being transparent to IR photons means that you'll still have, if you put 100 in one end, 50 out the other end, because the carbon dioxide in the atmosphere is still having that effect. So we conclude that the only important factor here is the partial pressure of carbon dioxide, i.e. the number of carbon dioxide molecules that's between the surface of the Earth and space. That will determine how many IR photons are scattered and absorbed, and how many escape and where they do as a function of altitude. Well, let's do a little calculation to see how many carbon dioxide molecules are blocking IR photons from escaping from the surface of the Earth into space. We can take a look at the number of molecules in a cubic meter of air, and that's 30 billion trillion molecules. So there's about 10 million trillion carbon dioxide molecules in a cubic meter of air if you consider there's 410 parts per million of carbon dioxide. So in our 1 square centimeter tube, 1 meter long, there would be about 100 trillion carbon dioxide molecules. Now that's an awful lot of carbon dioxide molecules, but we aren't finished yet. The atmosphere, if it was of uniform density, would be about 10 kilometers thick. So when you multiply that 1 meter by 10 kilometers, you end up with 100 million trillion carbon dioxide molecules between the surface of the Earth and space. They're all getting in the way of those IR photons trying to escape. But the real question is, how efficient are they at absorbing and scattering infrared photons? And the best way to conceive of that is to calculate the mean free path of an IR photon when it travels in the Earth's atmosphere. We can easily calculate the mean free path of an IR photon in the Earth's atmosphere before it strikes a carbon dioxide molecule, and that's about 70 meters. So that would say, for a uniform atmosphere 10 kilometers thick, that there'd be 143 encounters from the surface to the edge of space, where it can escape and cool the Earth. That's a fairly large number of interactions, and would be enough, in my opinion, to argue that there's enough carbon dioxide in the atmosphere to affect our climate. But it's not even as simple as that. because when an IR photon encounters a carbon dioxide molecule, it's scattered randomly, so half of them will be heading forward and half of them will be heading back. So it becomes a random walk process and thus a power series. So the number of photons that would get through without striking a carbon dioxide molecule, and so would be 1 over 2 to the power 143, which means that only one photon in 1 billion trillion 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 photons would get through, i.e. none. So this shows that there's plenty enough carbon dioxide in the atmosphere to be affecting the Earth's radiative balance and hence our overall climate. I think we've shown adequately that the percentage of the atmosphere that is carbon dioxide is irrelevant to the amount of global warming that we have. There are other active greenhouse gases as well, most effective of which is water vapor. Then comes carbon dioxide, methane, ozone, the various oxides of nitrogen, and CFCs in that order. We've also shown that there's enough CO2 in the atmosphere to affect the Earth's radiative balance and hence our climate. So the more carbon dioxide we put into the atmosphere, the more global temperatures will rise. And there's also another bad side effect of this, that our oceans will become more acidified as we put more carbon dioxide into the atmosphere, because they're absorbing quite a large proportion of the carbon dioxide that we emit. So if you see somebody using the silly argument that 0.04% is not enough carbon dioxide to be affecting our climate, please tell them they're full of nonsense and post them a link of this video. And so until next time, goodbye.